Okay, I'll start. I'll start, right? Yes. So I'm going to start a new series, and this new series is the solution series to previous year's linear algebra, right? Right. So in 2019, and if you haven't watched my linear algebra playlist, so please go through all the videos in linear algebra. And I want to make yes. So I want to make one important announcement is that actually when I uploaded linear algebra videos, I think I have uploaded linear algebra more than 1 year. Actually before 1 year I think I have uploaded, but when I was uploading there was a quality up to 480p. So when I was uploading, I uploaded only at 480p and 360p, but I don't know what happened to that video. But nowadays that first 15 videos are only playing at 240 pixel, right? So I have raised the complaint to YouTube, so I think you will get that quality back again, right? Because many are texting that the first 15 videos of linear algebra is very blurred, right? So I want to make that. I'm very sorry for that. So I'll try to make. So that's why I have started linear algebra solution series, right? So I'm not only going to cover this sum, I'm going to teach A to Z what are the definitions that are involved and how we can solve in one or two methods, right? So we're going to analyze every problem very detailed, right? So I'm not just going only to solve the problem, right? So we'll discuss more by taking a single problem, right? Yes. So first we're going to start 2019, right? So in real analysis we have started at 2018. So we have completed up to 2004, I think, right? So we have completed almost last 15 years question papers. So very soon I will finish that paper 2. And in calculus I have been going from backward to front. That is, I have started from 1992. We are going up to 1996 and 1997, I think, I don't know. So please go through all the playlists, right? Yes. So that's it. So I'll try to get back the quality for that video, right? Because you can see only a 240 pixel. So I'll try to improve that, right? Yes. So if you have watched that playlist, I think every problem will be very easy for you, because I have explained all basic definitions and basic problems also. I have solved many problems, right? Yes. So we'll move on to the first problem. So let T is a function from R2 to R2 be a linear map such that T of 2, 1 is equal to 5, 7 and T of 1, 2 is equal to 3, 3. If A is the matrix of T corresponding to the basis E1 and E2, find the rank of A, right? So it is given that T is a transformation from R2 to R2, right? So it takes some from vector from R2 vector to R2 vector. It is given that T is a transformation. Linear map and linear transformations are both same. So it taking 2, 1 to 5, 7 and it taking 1, 2 to 3, 3, right? So in general we need to find the matrix of this corresponding transformation, right? So before finding transformation, first what we need to do is we need to find T of x, y, right? So after finding T of x, y, I can find the matrix of T corresponding to the basis E1 and E2, right? Where E1 and E2 are standard basis. So here E1 where E1 and E2 are standard basis, right? Yes. So first we will find T of x, y. After finding T of x, y, we will find the matrix for this transformation with respect to the standard basis, right? Yes. So what they have given is, so they have given that T of 2, 1 is being mapped to 5, 7 and T of 1, 2 is being mapped to 3, 3, right? Yes. Now we need to find that first we need to find T of x, y, and then we can find the matrix of this transformation with respect to the standard basis. We call that matrix to be A, and then we need to find the rank for that matrix, right? Yes. So how we can find T of x, y? T of x, y, how we can find? So what the important thing is, if you know the image of basis vector, then you can find any vector in the linear combination of basis vector, right? So I think you know what's meant by basis, right? So first let me tell you a quick recap or quick note about basis. So we say a set is a basis, right? So we say this set is a basis if this set is linearly independent and if this set spans the entire space, right? So spans the entire space. So if this set is linearly independent, linearly, then I want to say what's meant by linearly independent, right? And then I want to say what's meant by span. Then only you will understand the definition of basis, right? So there is one set. I can call that set to be a basis if that set is linearly independent and if it spans the entire space. So what is meant by linearly independent? So I think I don't want to talk about this, right, because these are very basic definitions, and please go through the linear algebra playlist of me so that it will be very easy for you, because if I talk about for every definition it will be very long. Yes. So first what I am going to do is I am going to show whenever if we have a problem like they will give certain conditions like, so first we want to show that the input vector, so what is our input vector? 2, 1 and 1, 2. So first we need to show that this set is linearly independent, because if the set is basis only, then we can find the corresponding transformation, right? So we can find a matrix for T with respect to basis only, right? So if it is a basis only, then we can find the corresponding matrix for that transformation. So first what we need to verify is whether this set is basis or not, right? So first we need to show whether this 2, 1 and 1, 2 are basis. If I show that this is a basis, then I can write any element as a linear combination of these two terms, because it is basis, it is linearly independent and it spans the entire space. Spans means with the help of these two vectors I can get back all the vectors, right? So whatever vector you say, suppose if you are saying 1, 2, I can bring 1, 2 with the linear combination of these two vectors. So whatever vector you give, I can find your vector with a linear combination of these two. Linear combination means sum a into 2, 1 plus b into 1, 2. A and b are real number. So whatever vector you give, I can always find your vector with the help of these two vector only if I say this set is a basis, right? So first what I am going to show is I am going to show that this set is a basis. So in order to show it is a basis, what I need to do? I need to check whether this set is linearly independent. First I need to show it is linearly independent. Now how can I show a set is linearly independent? We can show that in two ways. So we can show a set is linearly independent in two ways. So first is if this determinant is non-zero, then it will always be linearly independent. Linearly independent means we cannot write one vector with some multiple of another vector, right? We cannot bring one vector with the help of this vector. If I can bring this vector with the help of this vector, then we say both are linearly dependent. For example, if I take 1, 2 and 2, 4, if I take 1, 2 and 2, 4, I can bring this vector. You can see I can write, if I take a 2 here, then I can bring this vector. So I wrote this vector from here. So when we say that these two are linearly dependent, suppose if I cannot like this, suppose if I have 1, 3, then you cannot bring this vector from this vector by suitable combination or some scalar multiplication. So how we can show this set is linearly independent is we can show either what are the vectors here 2, 1, 1, 2. You find the determinant for this, right? You find the determinant for this. If this determinant is 0, then it is linearly independent. If this determinant is non-zero, it is linearly independent. So in order to show linearly independent, you just transform this set to a matrix form and then you find determinant. If this determinant is 0, then it is linearly dependent. If it is non-zero, it is linearly independent. So you can see what is the determinant for this matrix. It is 4 minus 1, which is equal to 3, which is non-zero. So if determinant is non-zero, then these are linearly independent, right? So we have shown that this set is linearly independent. Or you can also use definition, right? So how you can also use definition to show that this set is linearly independent. So what does the definition says? If a into 2, 1 plus b into 1, 2 is equal to 0 means this means we need to show A is equal to 0, B is equal to 0. That is, if the only combination I can write 0 vector is either A has to A and 0, B is 0. If I show this, it is linearly independent. Suppose if I find A and if A is non-zero, if one of them is non-zero, it is linearly dependent, right? So if both A and B are 0, then it is linearly independent. If at least one is non-zero or both non-zero, it will be linearly dependent. This is the definition, right? So we say a set is linearly independent is alpha 1 v1, alpha 2 v2 up to alpha n vn is equal to 0 if and only if all the scalars has to be equal to 0. If you go through the book, this is the definition they will give. If at least one is non-zero, then these are linearly dependent, right? So if you go through the standard books, they will write this as a definition, right? So if all the scalars are 0, it is linearly independent. Now I am going to show these two scalars are 0, then it is also linearly independent. If at least one is non-zero, then it is one is non-zero or both non-zero, it is linearly dependent. So how can I prove this? So I can write this as 2a plus b is equal to 0, right? The first component is 2a, the second component is b. Here the second component is a, second component is 2b. So we will solve these two equations, right? You know how to solve these two equations and you can find the value of a and b. If both a and b are 0, then it is linearly independent. If both a and b are non-zero or at least one is non-zero, it is linearly dependent. So how can I find a and b here, right? So this is a homogeneous system or non-homogeneous system. It is a homogeneous system, right? Because our output vector is 0 vector. So if the output vector is 0 vector, then it is homogeneous, right? And it's homogeneous system. You know how to solve a homogeneous system, right? So this I can write this as 2, 1, 1, 2 into a, b is equal to 0, 0. This is a very elementary that you come across in school. This is the homogeneous system. So for homogeneous system, if this determinant is non-zero, then it is only trivial solution. So I think you will remember this. If the determinant of this is non-zero, then only trivial solution. Trivial solution means a is equal to 0, b is equal to 0. I am writing a and b here because our variables are a and b. If determinant is determinant is 0, then it is non-trivial solution exists. This is the basic definition, right? Non-trivial solution exists. And how we can find non-trivial solution? We will use some number of free variables. We will use free variables to find the non-zero trivial solution. Now you can see this determinant is non-zero. That means only trivial solution. That means a has to be equal to 0, b has to be equal to 0. That means a has to be equal to 0, b has to be 0. That means it is linearly independent. So we can show that either by this way or this way that this set is linearly independent. So next we need to show that this set spans the entire space, right? This set spans the entire space. Now, so first I have shown that it is linearly independent. So maximum you can see this 2, 1, 1, 2 a subset of R2, right? 2, 1 and 1, 2. So 2, 1 and 1, 2 is a subset of R2. 2, 1 and 1, 2 is a subset of R2. And let me keep this as it is. Now you can see whenever it is linearly independent, 90% there is a chance that it will span the entire space, right? So if it spans the entire space, what is the condition then? So suppose if it spans, what that means, for any vector, if you take any vector in R2, I can write this vector as a linear combination of these two basis vector, right? So as a linear combination of these two basis vector, that one means, right? So you give me any vector, I can always write that vector as a linear combination of these two basis vector, because I have shown that these two are linearly independent. Now we need to find x and y. So I can write this as x, y is equal to, this I can write this as 2a plus b, 2a plus b, comma a plus 2b. This means x is equal to 2a plus b and y is equal to a plus 2b. Now we need to find x comma y in terms of a and b, right? You need to find x comma y in terms of a and b, because a and b is a real number, right? You have to find x comma y with the help of only a and b. So how I can find x comma y? I need to find x comma y, right? I need to find x comma y. So if I multiply 2 here, this will be 2a, this will be 4b, this will be 2y, right? Or let me I'll get back 1 minute, slight problem here. Yes. Now let me get back into the problem. Now we need to solve this equation, right? So we need to find the value of x and then need to find the value of y, right? I think this is normal. You can solve this by elimination method, right? So if you multiply 2 here, this will be 2a, this will be 2y, and this will be, I think I didn't write right, 2x. Oh, I think I have made some mistake here. Okay, let me do like. Okay, let me. So first we have shown that this vector is linearly independent. Now let a comma b belongs to R2. So instead of x comma 2, x comma y, I will take just for the convenient a comma b. So I can write a comma b as x into the basis vector, right, 2 comma 1, and y in a into x into 2 comma 1 plus y into 1 comma 2, right. So from this you can see this a comma b is equal to 2x plus y comma x plus 2y. That means 2x plus y equal to a and x plus 2y is equal to b, right, x plus 2y is equal to b. Now we need to find the value of this x and this y, right, you need to find the value of this x, this y, or you can also find the value of, yes, so this is our main. Now we need to find the value of x and y with a combination of a and b. So how I can solve this? So if I multiply 2 here, this will be 2x, this will be 4y, this will be 2b. Now we cancel this will get cancelled. So here we have y minus 4y, so minus 2y, a minus 2b. This I can write this as y is equal to, so I am just taking minus common here, so we have 2b minus a by 3, right. So we have found y. So we substitute y here, you will get the value of x. So we will get the value of x to be equal to 2a minus b by 3, right. So you can write any vector as a linear combination of these two basis vector. Now you find a and x and y. Now you want to find the value of x and y with the help of as a linear combination of a and b. So what we have found is So x is equal to 2a minus b. So that means a comma b is equal to, so x what we have found is 2a minus b by 3 into 2 comma 1 plus y which we found is 2b minus a by 3 into 1 comma 2, right? Yes. Now it is given that it is a linear map. Now I am going to apply t on both sides, right? So what? So I think it's very easy. First I have shown that this is linear independent. Then for any vector a comma b in R2, I can write a comma b as some linear combination of x into 2 comma 1 plus y into 1 comma 2. Now I need to find the value of x and y in terms of a and b, which I found earlier. Now I am going to apply t on both sides. So therefore t of a comma b is equal to, now it is a linear transformation. That means t of ax plus by is equal to a into t of x plus b into t of y, right? A into t of x plus b into t of y. So this I can write this as, I can treat this entire term as constant. So I can bring this term outside. I can apply t only to 2 comma 1, and again I can take this as constant outside because it is a linear map. This is nothing but t of 1 comma 2. Now it is already given that, so 2a minus b by 3, so it is already given that t of 2 comma 1 is 5 comma 7, right? And it is 2b minus a by 3, and t of 1 comma 2 it is given that it is 3 comma 3, right? 3 comma 3. Now you have to make a simplification to find t of a comma b. So after finding t of a comma b, you need to find the matrix for the standard basis, and then you have to find the rank for that. Now if you simplify this, so 5 into this plus 3 into this, you will get the first component, and 7 into this term plus 3 into this term, you will get the second component, right? Yes. So we have 5 into this, right? 5 into this will be 10a minus 5b by 3 plus 3 into this component. So 3 into this component, this 3 will get cancelled. So we have 2b minus a. Now what will be the second component? 7 into this term. So 7 into this term will be 14a minus 7b divided by 3, and 3 into this term. Again 3 will get cancelled. So we have plus 2b minus a. Now we make LCM, and then you find t of a comma b. So if we make a simplification, you will have t of a comma b is equal to 7a plus b by 3 and 11a minus b by 3. This is our transformation, right? So you can either find t of x comma y or t of a comma b. It is nothing but a signs, right? No problem about the denotation. That is the letter we are representing, right? So far what we have did to find this is, so first we have shown that these two vectors are linearly independent. You can show that either by determinant is equal to 0, or you can write that as a linear combination, and you have to show either a is equal to 0, both a and b are 0. And then I'm just taking an arbitrary vector a comma b in R2, and since it spans, so I can write that as a linear combination of these two basis vector. That is, I can write a comma b as some x into 5 comma 7 plus some y into 1 comma 2. I need to find the value of x and y as a combination of a and b. After finding that, apply t on both sides. Now we can apply only to t only to 2 comma 1 because it is a linear transformation. That means t of ax plus by is equal to a into t of x plus b into t of y. So I have found that. Now what I need to do is, I need to find the matrix for this with respect to the standard basis. So standard basis for R2 is, so our standard basis is 1 comma 0 and 0 comma 1, right? So now we need to find the matrix for this. So what will be my t of 1 comma 0? So we need to substitute a to be equal to 1, b to be equal to 0. So 7 into 1 plus 0 by 3, and then 11 into 1 minus 0 by 3, so which is nothing but 7 by 3 comma 11 by 3. And what will be my t of 0 comma 1? So you have to substitute a to be equal to 0, b to be equal to 1. So we have 1 by 3 minus 1 by 3, right? 1 by 3 minus 1 by 3. Now the matrix of t with respect to the basis, with respect to the standard basis, which we call that as A, because A is the matrix of t corresponding to the basis E1 and E2. So matrix of t with respect to the basis is, so t of 1 comma 0 is 7 by 3, 11 by 3. So write that as 7 by 3, 11 by 3. and what is the corresponding vector for 0 comma 1? It is 1 by 3 minus 1 by 3. Now we need to find the rank for this matrix, right? It's a very easy process. Now what is the rank for this matrix? We can see what is the determinant for this matrix, right? We can also take 1 by 3 outside, right? If I take 1 by 3 outside, I can write that as 7, 1, 11 minus 1, and you can see this clearly, the determinant is non-zero, right? Determinant is non-zero means rank has to be equal to 2 for n cross n matrix, right? So rank of A has to be equal to 2. So if we take 1 by 3 outside, this is nothing but 7, 1, 11 minus 1, and you can see determinant is minus 7 minus 11, which is minus 18. So non-zero. That means rank has to be equal to 2. If for n cross n matrix, if determinant is non-zero, then the rank is n, right? Yes. So I think we'll move on to the next problem. So I'll just make a quick overview. So first we have shown that these two are linearly independent, and I have taken an arbitrary vector a comma b, and I can write that as a linear combination of these two basis vector. So I have written a comma b is equal to x into 2 comma 1 plus y into 1 comma 2. I need to find the value of x and y with the help of a and b, and I have found that, and I applied t on both sides. So I have found t of a comma b, right? And we need to find the matrix with respect to the standard basis. That means I need to find 1 comma 0, 0 comma 1. So we have found the matrix of A to be equal to 7 by 3, 1 by 3, 11 by 3 minus 1 by 3, and then we have found the rank to be equal to 2. So we move on to the next problem. So this question is asked in 10 marks. I think I confused this problem. So second problem. There are 5 problems in 2019. So second problem is asked in 15 marks. Let A and B be two orthogonal matrices. Let A and B be two orthogonal matrices. Two orthogonal matrices of same order, and determinant of A plus determinant of B is equal to 0. Show that A plus B is a singular matrix. Is a singular matrix, right? So it is given that the A and B are orthogonal matrix, right? So A and B are orthogonal matrix. So and it is given that determinant of A plus determinant of B is equal to 0, right? Determinant of A plus determinant of B is equal to 0. Now we need to show that A plus B is a singular matrix. So first let me write what they were given, right? So proof, and this question is 15 marks. So A and B are orthogonal matrix. So given A and B are orthogonal matrix. So you know what's meant by orthogonal matrix, right? That means A into A transpose is same as A transpose into A is equal to I. So when two matrix orthogonal, A into A transpose is equal to I. And again B is orthogonal matrix. That means B into B transpose is same as B transpose into B, that is same as an identity matrix of order n, right? Now we will consider only any one, right? We will consider only any one. So we have A into A transpose is equal to I. That means if I take determinant on both sides, so determinant of A into A transpose is equal to determinant of I, right? Or else we will write In, so identity matrix of order n, right? Now determinant of AB is determinant of A into determinant of B. So I can write this as determinant of A into determinant of A transpose, and determinant of identity matrix always be equal to 1. Now determinant of A transpose is always same as determinant of A. So this implies determinant of A square is equal to 1. So if A is an orthogonal matrix, determinant of A square will be 1. So similarly B is also an orthogonal matrix. B is also an orthogonal matrix. Now again taking determinant on both sides, so B into B transpose is equal to determinant of In. and again determinant of B into determinant of B transpose is equal to 1, and determinant of B transpose is same as determinant of B, and again determinant of B square is equal to 1, right. So I can also write this as also determinant of A square is equal to 1 and determinant of B square is equal to 1, right. So I can erase this one. This is, I can write away this straight away, but I will give the proof for that, right. So this is here is the proof. Now, so from only these two data we have write this information. Now it is also given that that determinant of A plus determinant of B is equal to 0, right. So A and B are orthogonal matrix and determinant of A plus determinant of B is 0. Now what we need to prove? To prove A plus B singular matrix. That means when we say a matrix is singular, if the determinant is equal to 0, then it is singular matrix. If the determinant is not 0, then it is not singular matrix. So that is, we need to prove determinant of A plus B is equal to 0, right. So if I prove that, this implies A plus B is a singular matrix. A plus B is a singular matrix, right. So I need to prove determinant of A plus B is equal to 0. I have this information, right. Yes. Now we know that determinant of A plus B whole square, right, determinant of A plus B whole square is equal to determinant of A square. Let me get back to that. Yes. Now we know that determinant of A plus B whole square, that is nothing but A plus B whole square formula. Determinant of A square plus determinant of B square plus 2 times determinant of A into determinant of B. This we have already know, right. Yes. Now what I can do is, determinant of A square value is 1, right. Determinant of A square value is 1 and determinant of B square value is also 1. So we have 2 times determinant of A, determinant of B. That means we have 2 plus 2 into determinant of A into determinant of B, right. Yes. Now I can also write this to be, so we have determinant of A plus determinant of B is equal to 0. From this I can also write this as determinant of A is equal to minus determinant of B, right. From this I can also write determinant of A is equal to determinant of minus B. I will mark this as 4. Now if I use 4, this I can write this as 2 plus determinant of A, or we will write, you can take any, right. If I want to change A to be equal to B, then I can write determinant of A to be equal to minus determinant of B into determinant of B is already there, right. So this is nothing but 2 minus 2 into determinant of B whole square. What is determinant of B whole square? It is equal to 1. That means it is equal to 2 minus 2 into 1, which is equal to 0. So we have proved that determinant of A plus B whole square is equal to 0. This means determinant of A plus B is equal to 0. This means A plus B is singular. That's it. This question carries 15 marks. It will not take a 2 or 2 minutes to prove this, right. The singular matrix, right. So we need to prove A plus B is a singular matrix. So that means the determinant of A plus B has to be equal to 0. From these 4 information, I have just substituted in this formula to get determinant of A plus B is equal to 0. So now we move on to this is the third problem, right. This question is a 15 marks question. So rather than writing a essay for 15 marks for 2 pages or 3 pages, and then you have to think that it will take 10 to 15 minutes, you can see this question, you can finish this in 2 minutes to get 15 marks, right. So you want to know the importance of choosing maths as an optional. If you perform well, right, if you sincerely preparing, you can easily crack. When you are comparing sociology, so you have to write 19 questions in a single paper, right. So now we move on to third problem. Third problem is a 10 marks question. If A is equal to, so please take notes in your own, don't expect notes in my side for solution series, because I am also writing only in board and I am not doing the rough work and then I am straight away doing this, right. So I don't have notes. So I just have a question here, that's it. So we'll move on to third problem. So third problem is 10 mark question. If A is equal to 1 to 1, 1 to 1, 1 minus 4 1, 3 0 minus 3, 3 0 minus 3, and B is equal to 2 1 1, 2 1 1, 1 minus 1 0, 2 1 minus 1. Show that AB is equal to 6I3. Use this result to solve the following equation: 2x plus y plus z is equal to 5, x minus y is equal to 0, 2x plus y minus z is equal to 1. Now we need to show that AB is equal to 6. Now we need to show that AB is equal to 6I3, right? It's a very elementary. You need to multiply these two matrices. You have to get a identity matrix with diagonal 6, right? So I think you can do that, right? I don't want to do AB is equal to 6, and then use this result to show that you need to solve. Use this result to show. Use this result to solve, right? Use this result to solve 2x plus y plus z is equal to 5. This is a non-homogeneous. Non-homogeneous means when the RHS is at least 1 and 0, then it is non-homogeneous. So you can see 5 0 1, that is output vector is a non-zero vector. So the output vector is a non-zero vector, then it is a non-homogeneous. So we need to solve this. You can solve this method any way. There are matrix inversion method, there are Kramer's method, there are Gauss elimination method, there are Gauss Jordan method, there are Gauss Seidel method, Gauss Jacobi method, right? There are infinitely many, and then Kraut's method, there are many methods. So I always prefer to use Gauss elimination method. So before that, first we need to prove this with the help of this result. With the help of this result only we are going to prove this. Now first we need to show AB is equal to 6I3. Now you can take this exercise, right? You need to multiply these two matrices. So you multiply AB, you will get this as an answer: 0 6 0, 0 6 6. You will get this as an answer: 6 0 0, 0 6 0, 0 0 6. So you will get this as an answer, right? You just have to make a normal multiplication. So you can see 1 into 2 is 2, 2 plus 2 plus 2, so you will get 6. 1 minus 2 plus 1, so 1 minus 2 plus 1 is 2 minus 2, which is 0. So you can prove that. Now we need to solve this system, right? So you can show AB is equal to 6I3. Now we need to, so we have shown this, we need to solve this equation. Now consider, so we need to solve this system, that is 2 1 1, 1 minus 1 0, 2 1 minus 1, right? X coefficient, y coefficient, j coefficient. So 2 1 1, 1 minus 1, here we don't have a z, so 0, here 2 1 minus 1. So here how many unknown variable? It is x y z, and the output vector is 5 0 1. Now if you carefully examine this, you can see this is nothing but our B matrix, right? This is nothing but our B matrix. Now what I can do is, I can write this entire matrix to be equal to B, right? Because B is our this matrix, and I can write x, y, z into 5 0 1. Now in order to find x, y, z, I can write this x, y, z as, this is by matrix inversion method, right? So I can write x, y, z as B inverse into 5 0 1. So in order to find x, y, z, I need to find B inverse into 5 0 1. So in order to find B inverse, what you have to do? You need to you can use the formula adjoint of B into 1 by determinant of B into adjoint of B. So you need to find determinant for this matrix, and you need to find adjoint for this matrix, but you should not do that, right? It will take time. So when you, from this equation, you will have you have AB is equal to 6i. AB is equal to 6i. Now from here what I can get is, so if I post multiply, okay, if I pre-multiply A inverse, right, I will pre-multiply A inverse. If I pre-multiply A inverse, what we will have, right? Okay, if I pre-multiply A inverse, this will be A, okay, I need to find B inverse, right? So what I can do is, okay, don't think too much. So I can write B to B, I need to find B inverse. How I can find B inverse from here? How I can find B inverse? Okay, don't think too much. So I can write B to be equal to 6i by A, right, 6i by A. Then what will be my B inverse? Our B inverse will be, it will get tripled. So we have A by 6i, right, A by 6i, or we can also prove this by B inverse. Okay, let me do like this, right? Let me do like post multiply B inverse. Post multiply B inverse, right? I am post multiplying B inverse on both sides. Now what will be B into B inverse? It is nothing but I, and I into B inverse is nothing but B inverse. What is A into I? It is A. It is 6B inverse. So from this I can find B inverse is equal to A by 6, right? So before I can write now B inverse to be equal to A by 6 into 5 0 1. Now what you can do is, you can simply multiply A matrix with a vector 5 0 1 to get the required xyz. Therefore what we need to find is 1 by 6. So A is 1 2 1, 1 minus 4 1, 3 0 minus 3 into 5 0 1. 5 0 1, right? So just make a calculation here. So 1 into 5 is 5, 5 plus 0 plus 1, 5 plus 0 plus 1, 3 into 5 is 15, 15 plus 0 minus 3. So this is nothing but 1 by 6 into 6 6 12. So this is nothing but 1 1 2. Therefore the solution is 1 comma 1 comma 2, right? So x is equal to 1, y is equal to 1, z is equal to 2. This is our solution, right? So I'm using this method because when I write this as a Ax is equal to B format, you can see this matrix turns out to be B matrix. This matrix turns out to be B matrix. So that's why I'm using this information, right? Suppose if I simply give this data only, I have to find determinant of B and adjoint of B. But here we have to use this result. To solve this equation, right? So in order to find B inverse, you don't need to use the formula. So you don't need to use the formula. B inverse is equal to 1 by determinant of B into adjoint of B. So time waste. You can also do that, but it's a time waste. So what you can do is, you can simply write B inverse to be equal to A by 6, and then you can multiply A matrix with the output vector to get our values x, y, z, which is 1 comma 1 comma 2. This is our answer. So we move on to the next problem. So still there are only 2 problems left. This question is asked in 15 marks, 4th problem. I'm just searching for the question. Yes. This question is asked in 20 marks, right? So I'm going to prove the 4th problem, and this question is asked in 20 marks. So far we have solved 3 problems. First question 10 marks, second question 15 marks, third question 10 marks. So 35 marks from these 3 questions. Now I'm going to solve the 4th problem, and this question carries 20 marks, right? The 4th problem 20 marks. Very easy problem. Let A is equal to 5 7 2 1. 1 1 minus 8 1, 2 3 5 0, 2 3 5 0, 3 4 minus 3 1, 3 4 minus 3 1. This is our matrix. Find the rank of A. First is find rank of A. These are very elementary, right? Rank of A. Second is find the dimension of the subspace. Find dimension of the subspace V, set of all x1, x2, x3, x4, x1, x2, x3, x4 belongs to R4, such that A into x1, x2, x3, x4 is equal to 0, right? So we need to find the rank for this matrix and then need to find the dimension of the subspace this. Now I think you can find the rank for this matrix very easily, right? So just make some just change R1 to R2, interchange R1 and R2. So you will have a first entry to be equal to 1 and then you make R2 is equal to R2 minus 2 R1, R3 is equal to R3 minus 3 R1, R4 is equal to, you can make some transformation. So if you do that, you will get the reduced matrix. So the equivalent matrix for this is, so I am not going to do that, it's a very easy process. So if you reduce this matrix, you will have 1 1 minus 8 1. So I am just first I am changing R1 and R2 and then I am making R2, R3, R4, I am making transformations. So you get this matrix 0 1 21 minus 2 0 0 0 0 0 0, right. So what is the rank for this? So rank of A is the total number of non-zero rows, therefore rank of this matrix is equal to 2, right. Now if you just reduce this matrix, so first you change R1 and R2, so you will have first row to be 1 1 minus 8 1, second row to be equal to 5 7 2 1 and then you make some transformations, right. Yes. So this is our reduced matrix. Now we need to I think first problem is over, the rank will be equal to 2. What is the dimension of the subspace? We need to find the dimension of this subspace such that A into x1, x2, x3, x4 is equal to 0, right. What is our A? A is a given matrix, right. A is a given matrix. So what is our A? So I am straight away moving on to second subdivision. So I need to find the dimension for this. So A into x1, x2, x3, x4 is equal to 0. This is nothing but we need to find the null space. So we need to find the dimension for null space, right. What is the null space? Null space is the set of all vectors that are mapped to 0 and dimension of the null space is called nullity. So simply if they ask us to find nullity also, the same thing we need to find. Nullity is the dimension of the null space. What is the null space? The set of all vectors x1, x2, x3, x4 in R4 that are mapped to 0. So A into x1, x2, x3, x4 has to be equal to 0. So we need to find the dimension, right. You can straight away find the dimension, right. How many free variables are here? We need to find x1, x2, x3, x4, that is we need to solve this equation. We need to solve for x1, x2, x3 and x4. What is this? This is a homogeneous system, right, because our output vector is a 0 vector. So it is not just a single 0, it denotes 0 0 0 0. You should think that as 0 0 0 0. So this is nothing a homogeneous system, right, homogeneous system, and you can see this determinant is equal to 0 because if one row is 0, determinant will always be equal to 0. That means non-trivial solution exists. That means 0, we already know that 0 vector always mapped to 0 vector if it is a linear transformation. From this what we infer is other than 0 vector, some other vectors also mapping to 0. That means here this is our R4 and this is our some other R4 and this is our transformation, right. This is our T of x1, x2, x3 is equal to something. So we already know that 0 0 0 0 will always be mapped to 0 0 0 0, but from this what we infer is some other non-zero vectors also mapping to 0. Then what are the non-zero vectors we need to find, right. So we need to solve this equation. Now this is a homogeneous equation and it has non-trivial solution. How to solve a homogeneous system if it has a non-trivial solution? Now we need to find free variable. So first we need to find number of free variable. Or before moving that, we have already reduced this to the rank form, right? Then only you can proceed up to this. Suppose in the exam, if they give some matrix and they ask us to find null space, means what you have to do? First you have to reduce this matrix to this form, right? Straight away you should not do like this. You have to reduce this matrix as much as I can. So what I am saying is, suppose if they gave this matrix and if they ask us to find null space, we should not straight away write that matrix into it. You have to write, but what you have to do is you have to reduce this matrix to as long as you can, so that most of the entries are 0. Right? After reducing only, you need to go through the steps I am writing here. So it is a homogeneous and determinant is equal to 0. It has non-trivial solution. So from this, if I multiply this, we will have x1 plus x2 minus 8x3 plus x4 equal to 0. And if I multiply this, we will have x2 minus 21x3 minus 2x4 is equal to 0. So we have only 2 equations. That means we have only we need to find number of free variable. So number of free variable is equal to, we have formula for free variable. What is the formula? It is nothing but n minus rank of a. N is the total number of variable. How many variables are there in total? We have 4 variable. What is the rank? It is equal to 2. So we have 2 free variable. So that means I can assume any 2 variable in my own, right? I can assume any 2 variable in my own. So number of free variable denotes the number of linearly independent set, right? Because that 2 are linearly independent, because I can take any value that. So that means our dimension has to be equal to 2. So we will write this formally. So number of free variable is 2. That means from 4 variable you can assume any 2 variable in your own. So we have 4 variable. So you can assume any 2 variable. So let x3 is equal to x, x4 is equal to t, whatever variable you can use. So I need to find x1 and x2, right? So from this I can find x2, right? We have from we'll mark this as 1, we'll mark this as 2. So from 2 we have x2 to be equal to 21. If I bring the term to this side, actually this is plus, right? This is plus. X2 to be equal to 2x4 minus 21x3. So we have assumed x4 to be equal to t and x3 to be equal to x. So we have 2t minus 21s. Now we need to find x1. So from 1 we can find x1, right? So from 1 we have x1 is equal to, so we bring these 3 terms to that side. So we will have minus x2 plus 8x3 minus x4. Now we substitute x2. So minus x2 it will be minus 2t plus 21s plus 8x3. So x3 is s minus x4 is t, right? x4 is t. Now you need to simplify this. So you can see this will be minus 3t plus 29s. So we have found the solution set. So if they ask us to find the dimension, means, okay, let me finish this and then I will explain more, right? So there are many more concepts hidden in this. So that means our x1, x2, x3, x1, x2, x3, x4 such that this A into x1, x2, x3, x4 is equal to 0 is the set containing what is our x1? Our x1 is, which we found is x1 is minus 3t plus 29s and x2 is 2t minus 21s and x3 is s3 is. So this means, so what is the dimension for this? What is the dimension for this set? These are the 2 independent variable, and you can see this and this both depend on t and s. So therefore dimension is equal to 2. So dimension of subspace is 2. So what this mean is, if you just substitute random values, right? If we just substitute t is equal to, let us substitute t t is equal to 1, s is equal to 0, right. So if we substitute t is equal to 1, s is equal to 0, we will have minus 3 into 1 plus 0, and here we will have 2, here we will have st 0 1. So we will get this vector. What this vector denotes means this vector is also mapping to 0. That's what this means, right. So we are finding all the vectors that are mapped to 0. Since this is denominator is non-zero, we have showed that non-trivial solution exists. That means 0 vector is not only the one that is mapped to 0. There are some other vectors. If there are some other vectors, there has to be infinite number of vectors, right. There are infinite number of vectors that are mapped to 0. What are they? These are them, right. So if you vary s and t, here s and t are real number. So you will have infinite set of solutions. Rather than I am telling solution, I could say these are the 4 vectors from the domain that are mapped to 0 in the codomain, right. If you these minus 3 2 1 minus 3 2 0 1 will be mapped to 0. If you substitute t, s is equal to 3, t is equal to 4, that will also map to 0. If you substitute s is equal to 1 lakh, t is equal to 10 lakh, you will have a vector that will also map to 0. That's what this means, right. So this question carries 20 marks. So if you have practiced this question will not even take up to 5 minutes, right. So only thing you have to find the rank, that's it. Now we will go for the last question in this year. So last question, that is the 5th question, and this question is asked in 15 marks. So far we have 2 10 marks, 2 15 marks and 1 20 marks. That means 2 10 plus 10 is 20, 15 plus 15 is 30. So 70 marks we have got only from linear algebra, right. So you can get 70 marks very easily, right. So 70 marks you can get in, you can finish this entire 7 problems in just 30 minutes or 35 minutes. So in 30 minutes you are getting 70 marks, right. So please prepare very well, right. I am here to help you. So it's actually very easy. Only thing is you need dedication and practice, that's it, right. If you focus on mechanics and fluid dynamics, I am sure you will crack marks, right. The only thing is you have to focus on, these are very easy, right. The only thing you have to focus on, because that is very vague, I think. So focus on mechanics and dynamics, fluid mechanics and dynamics, you will be successful in maths optional, right. So state Cayley-Hamilton theorem. So 5th is state Cayley-Hamilton theorem. State Cayley-Hamilton theorem. State Cayley-Hamilton theorem. Use this theorem to find a power 100, where a is equal to 100, 100, 101, 010, right. So we need to find a power 100, right. So if you imagine itself is very big, we need to multiply this matrix 100 times. So first we need to state Cayley-Hamilton theorem, right. What Cayley-Hamilton theorem says? Every square matrix satisfies its own characteristic equation. That is what Cayley-Hamilton theorem, right. So every square matrix, so I already explained this in playlist. So every square matrix satisfies its own characteristic equation or characteristic polynomial. So first we will find the characteristic polynomial for this matrix. So we will find characteristic polynomial. So you need to find the characteristic polynomial for 100, 101, 010. Right? You need to find the characteristic polynomial for this. So this is 3 cross 3 matrix. I have already given the formula. So characteristic polynomial is lambda cube plus s1 lambda square, lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Equal to 0 means you will find eigenvalues. So this is our characteristic polynomial, right. This is equal to 0. This is our characteristic polynomial. So what we need to find s1, s2, s3, and then we need to substitute here. So what is our s1? S1 is the trace of A, trace of the given matrix. So let this matrix be equal to A. So what is the trace of A? Trace of A is the sum of diagonal element. So that means what is the diagonal element here? 1 0 0. So 1 plus 0 which is equal to 1. What is S2? S2 is the sum of minus of diagonal, sum of minus of diagonal. So you need to find the minus for diagonal. So what is the first diagonal element here? 1. What is the minus for 1? To delete the corresponding row 1 column, you will end up with the 2 cross 2 matrix 0 1 1 0 plus what is the minus for 0? Second diagonal 0. This will get this column, this row will be gone. So 1 0 0 0 1 0 0 0 and third diagonal is 0. And what is the minus for this diagonal? So this column, this row will get cancelled. So we have 1 0 1 0 1 0 1 0. The important thing is you should not multiply the minor number here, right? So only thing you have to find is the minor for diagonal, right? So this is 1 0 0 1 0 0 1 0 1 0 1 0, right? So this is our first diagonal and minor for this is 0 1 1 0. This is our second diagonal and minor for this is 1 0 0 0. Third diagonal is this and minor for this is 1 0 1 0. So expand this will be 0 minus 1 plus this will be 0, this will be 0. So this is nothing but minus 1. What is S3? S3 is the determinant of A. S3 is determinant of A. So you find the determinant for this. So for a spine determinant, you can only expand these two are 0. So we expand this, so we will have 1 into 0 minus 1. So we have minus 1 to be equal to determinant. So we have found S1, S2 and S3. S1 is the trace, S2 is the sum of minor of diagonal, S3 is determinant. So what will be my characteristic polynomial? It is lambda cube minus S1 is 1. So we have 1 into lambda square plus S2. S2 is minus 1. So we have minus lambda. Already we have minus S3. S3 is minus 1. So this will be plus 1 is equal to 0. Right? I am just substituting S1, S2, S3 here. So characteristic polynomial is lambda cube minus lambda square minus lambda plus 1. So what Cayley-Hamilton theorem says? Cayley-Hamilton theorem says is that every square matrix satisfies its own characteristic equation. That means in place of lambda we substitute A. We have A cube minus A square minus A plus I is equal to 0. You have to write constant as I. Now you find A cube, you find A square, you find A and then you find I. You perform this operation, you will get a 0 matrix as your answer. So we have so from characteristic polynomial we have A cube minus A square minus A plus I equal to 0, right? A cube minus A square minus A plus I is equal to 0. Now from this what I can conclude is A cube is equal to A square plus A minus I, right? I can mark this as equation number 1, right? A cube is equal to A square plus A plus I. A cube is equal to A square plus A minus I. Now what will be, I need to find A power 100, right? So first I need to find some pattern here. So in order to find some pattern, so what will be A power 4? A power 4, I am going to multiply A on both sides. So this will be A cube, so multiply A. So this will be A power 4, this will be A cube plus A square minus I. Now I can use I am going to replace A cube to be equal to A square plus A minus I plus A square minus I. This is by 1. So by 1 I can replace A cube to be this. So this I can write this as 2A square plus A minus I, right? 2A square plus A minus I, 2A square plus A square, A cube plus A square minus I. A cube is A square plus A minus I. Where I am making mistake, yeah, this will be A, right? So multiply A, this will be A. So this will be A, sorry. This will be A minus I. So this 2 will get cancelled. So we have 2A square minus I. 2A square minus I. So what will, again if I multiply A, so this will be A power 5 is equal to, A power 5 is equal to Now a power, this will be 2a cube minus a, right? I am multiplying a again. So this will be 2a cube, and again I into a is a. So again I can replace a cube to be equal to a square plus a minus I minus a. So this will be 2a square. Now if I multiply a, yes, 2a square plus 2a minus 2i minus a. So this will be 2a square plus a minus 2i. So what will be my a power 6? What will be my a power 6? So again if I multiply a, our a power 6 will be, if I multiply a again, so we will have 2 into a cube, and this will be a square, and this will be I into a is a. Now again I can replace a cube to be equal to a square plus a minus I plus a square minus 2a. So if I simplify this, we will have, you can see this 2a and this minus 2a will get cancelled. So we have 2a square plus a square will be 3a square minus 2i, right? Minus 2i. This is the answer we will have. Now if you examine a power 4, a power 4 is 2a square minus I, and a power 6. Is there any pattern for all even powers? Is there any pattern for all even powers? Now you find a power 8, right? You find a power 8. So just find a power 8. So first you need to find a power 7, and then you need to find a power 8. So you can see from a power 4 I have 2a square minus I, and a power 6 we have 3a square minus 2i, right? So you find a power 8 in your own, right? You just find a power 8 in your own. So we will have a power 8 to be equal to 4a square minus 3i. You just verify, you just find a power 8. Is there, can we generalize this? Can we generalize this? So if I try to generalize this, you can see if it is 4, here it is 2, right? If it is 4, here it is 2. So we are only generalizing for even terms, right? So if I generalize this, so we have a 2 power n is equal to, so here we have n, right? Here we have n, so we have n a square minus, here n is 3, here n minus 1 into I. Can I generalize like this? So you can see I can write this as a 2 into 2. So this is 2a square minus I. So this I can write this as a 2 into 3. So this is 3a square minus 2i. So this is a 2 power 4. This is 4a square minus 3i. So you can see n 2 2, 3 3, 4 4. So n, this will be n. Here you can see 3 is 2, 4 means 3, n means n minus 1. So I can generalize like a power 2n is equal to n a square n minus 1 I. So if I generalize, I can find a power 100. So if I need to find a power 100, put n is equal to 50. If n is equal to 50, this will be a power 100. This will be 100 a square minus 99 I, right? So 100 a square nothing but some product of a into a. So we already know what is meant by a. We already know what is meant by a. So you just find a square. So we have a to be equal to 100, 100, 100, 101, 010. So if you find a square, you just substitute a square value here. So a square matrix will be 100, 110, 101 minus, sorry, n is equal to 50, right? This is 49i. 49i minus 4900, 4900, 49. So when you subtract this matrix, this is our a power 100 matrix. So the first term will be, So we subtract these two matrix, so we have 100 minus 49. So 100 minus 49. Sorry, 50. Sorry. N is equal to 50, right? So 50, N is equal to 50 means 50 a square. Then only we get 100 here. So here 50. So 50 minus 49 is 1. 50 into 0 is 0. 0 minus 0 is 0, 0. 50 into 1 is 50. 50 minus 0 is 50. 50 into 1 is 50. 50 minus 49 is 1. 50 into 0 is 0. 0 minus 0 is 0. 50 minus 0 is 50 again. 50 into 0 is 0. 0 minus 0 is 0. 50 into 1 is 50. 50 minus 49 is 1. So this is our a power 100 matrix. Right? That's it. So we have solved all 5 problems that are asked in 2009 question paper. Right? So overall it carries 70 marks. It carries 70 marks. So all are very easy problem, right? All are very easy problem. So tomorrow what we will do is we will be solving 2018 question paper. So daily we will be solving one question paper from linear algebra for the next 20 days, 20 to 25 days, so that we will solve entire question papers on linear algebra. And from my experience, what I infer is that if you have a good basic knowledge in linear algebra, and if you solve all P by Qs from 1992 to 2018, I think you can crack the problem. So that's it, right? So tomorrow we will be solving 2018 question paper, right? Thank you. If you have any doubt, you can ask. If you have any doubt, you can ask from these 5 questions. Quick. If you have any doubt, you can ask quick. Yes. So and the important thing is, if you haven't joined the Telegram channel, you please join the Telegram channel for regular updates, right? Because there will be I will be sending all the links whenever if I am live. So Telegram group name. So I'll just type it here. So I'll just name. So it is you just go to Telegram, and then in the search box you type UPSC Max. So you just type UPSC space Max -PRASANNA17. You just type this channel, you will get our channel and then join for regular updates, right? Yes. So that's it. We'll see tomorrow. Thank you. Goodbye. Have a great night. Good night.